Hello, this is the video on Boyle's Law, section 14.1. I'm going to start out with a trivia question. What is the significance of the following sentence? The quick brown fox jumps over the lazy dog. I don't know if you have the answer or not, but I'll let you figure that out. And this is actually called a pangram. Trivia question number 2. What does PEMDAS stand for? Most people will get this right away. Hint is think math. And yes, it is. Parentheses, exponents, multiplication, division, addition, and subtraction. It's the order of operation that you do your algebra in. We're going to be doing a lot of algebra this unit. It's just some simple multiplications and divisions. But you must follow these rules so you can get the correct answers. So let's take a look at Boyle's law. We learned about the 4 variables the other day. Pressure, volume, temperature, and the number of particles. We're going to be dealing with those variables throughout this unit. For this section right here, we're going to be looking at Boyle's law, which just deals with pressure and volume. So it says, for a given amount of gas at a constant temperature, the volume of the gas will vary inversely with the pressure. So there's the word inversely. What inversely proportional means is one goes up, the other goes down. So if the volume goes down, the pressure will go up. If the volume goes up, the pressure will go down. We have our equation for this. P1V1 is equal to P2V2. It also can be written PV is equal to P prime, V prime. A number of different ways to write this. The whole key is that you will have initial volumes and pressures and final volumes and pressures. Doesn't matter which one is final, which one is initial. This could be initial or final, final or initial. Doesn't really matter. The whole key when you're doing these problems is to figure out which ones go together. Your initial pressure and your initial volume have to go together. Your final volume and final pressure have to go together. You have to keep those together. P1, V1. They have to be at the same time, at the same moment in time. And we can do that easily by writing down our knowns and unknowns, which we're going to want to do. To give you a better feel for this gas law, actually do an application. If you go to my website and go to the PowerPoint presentation, in that PowerPoint presentation, you will find, as you go through it, you'll find this word applet right here. You'll click on it. And when you click on it, you will be directed to a website. Be directed to a website. That looks something like this. And it is looking at Boyle's law. You have a syringe over here on the left-hand side that you can adjust to varying volumes, and you will get a pressure reading coming out here. There's a little lab activity to do. You can go ahead and do that to get a little bit of practice, a little bit of feel for what happens. So you can change the volume by grabbing onto the syringe here, stopping at a certain volume. As soon as you let go, it gives you a reading, and it plots out your data. So you can plot out the data like it calls for, number of different points, however you want to do that. And when you get some data points like it says, you can press the graph button and it will automatically graph it for you. Go ahead and print the results like it talks about down here, and you get your nice graph with your data points and so forth. Very good way to look at Boyle's law. Trying to get back here to the actual site. Okay, here we go. All right, so you can do that. So we have our formula, P1V1 is equal to P2V2. Let's do an example. The way I show you how to do this problem is the way I expect you to do every single problem in this entire packet. So here's our question. If 425 milliliters of oxygen is collected at a pressure of 9.80 kilopascals, what will the volume of the gas occupy if the pressure is changed to 9.4 kilopascals? The first thing you're going to want to do is to write down your knowns and unknowns. You want to write these down. V1 is equal to 425 milliliters. That's what we have at the beginning. If 425 milliliters is collected at a pressure of. So you know that these two numbers go together. So those are going to be your V1 and your P1. So you need to write those down. Keep those together. That's what I meant by keeping your things together. It says if you change the pressure to 9.40 kilopascals, what will the new volume be? So here we have our knowns and unknowns written down. You have to do this. You may think it's kind of silly to do that when we're just doing our Boyle's law, but after we get through 5 different gas laws, if you don't do it, you're going to come up with the wrong formula. You're not going to be able to figure out which formula to use. What is your V1, P1, T1? The combined gas law uses also temperature. So there's a lot of numbers going to be thrown at you. If you actually put them down, write down your knowns and unknowns, it'll make it a lot easier for you. So that's your first step, writing down your knowns and unknowns. The second step is to write down your formula. And yes, I want to see this on every single problem. P1, V1 is equal to P2, V2. Again, once we get into our 5th gas law, it's going to be a little bit confusing. But if you write down the formula, you write down your knowns and unknowns, it's going to be easy. Now all you need to do is substitute your numbers in. Take these numbers that you got out here and just throw them into your equation. Makes it very easy. So you have P1. Well, here's your P1. 9.80 kilopascals times, there are times V1. Here's our V1, 425 milliliters, equals our P2, 9.40 kPa, and we have times V2. V2 is our question mark. That's what we're trying to solve. Now it's just your simple algebra. Divide it out. You need to get your unknown, your V2, on the one side. So you need to take everything on that side. 9.40 kilopascals. Whatever you do to one side, you must do on the other side. 9.40 kilopascals. And now we can do our calculations. Do your 900 or 9.80 times 425 divided by 9.40, and we will get our answer for V2. So our V2 will equal 443 milliliters. So that's going to be our final answer, 443 milliliters. 3 significant figures, because we have 3 significant figures in our numbers here. That concludes our presentation. Hopefully you found it interesting and understand it.